Hello, my name is MJ McDermott. I'm a meteorologist with a degree in atmospheric sciences from the University of Washington, and I do the weather on the morning news show on Channel 13 in Seattle. If you want to know how I got involved in helping improve math standards in Washington State, stay tuned. But first, let's get right to it. I have a question for you. Do you think that students in Washington State should learn multiplication and division with mastery by the end of the 5th grade? If so, you must insist that schools and school districts not use these curricula, reform math curricula called Investigations in Numbers, Data, and Space, often called TURC, or Everyday Mathematics. Now let's do some math. Oh wait, one definition first. An algorithm is a systematic method of solving a certain kind of problem. Now here is the standard algorithm for double-digit multiplication. Let's do the problem. 26 times 31 equals, I don't know. So let's write it like this. The standard algorithm goes like this. 1 times 6 is 6. 1 times 2, although it's not a 2, it's a 20, is 2, or 20. 3 times 6 is 18, 8. And then we carry the 1. 3 times 2 is 6, plus 1 is 7. And we do the addition. Sometimes we put a 0 here. 6, 8, and 2 is 10. Carry the 1, or the 100. And the answer, 806. A lot of parents learn this and know this as double-digit multiplication. The standard algorithm is efficient, works every time, and most parents know how to do it. In TURC investigations, no algorithms are taught. Instead, students are encouraged to reason through problems with something called cluster problems. Let me show you an example right out of the teacher's manual. All right, same problem, 26 times 31. So the student reasons, well, I know that 26 times 31 equals 20 times 31 plus 5 times 31 plus 1 times 31, because 20 plus 5 plus 1 equals 26. There it is. So how do I find 20 plus 31 times 31? Well, I know 10 times 31 is 310. And I can figure out from mental math that 20 times 31 is twice this. And I can figure out that that's 620. Now I need to know the 5 here. 5 times 31 is going to be half of this. So I can figure out from mental math that that's 155. So I add that to the 620, and I get 775 so far. So now all I need is one more. And I know 1 times 31 equals 31. And then I just add the 775 here, and I get 806, my answer. Students who learn math via TURC investigations rarely become efficient, confident, and fluent math users. Now, everyday mathematics does teach algorithms, just not the most efficient and least error-prone, the standard algorithm. Instead, it uses a focus algorithm, the partial products method. Same problem, 26 times 31. We set it up like the traditional algorithm, but instead we're going to multiply each piece by each piece. I'll show you. 1 times 6 is 6. Here it is over there. 1 times 2, but it's not a 2, it's a 20. The idea being that this teaches place value better than the standard algorithm. 3 times 6, but it's not a 3, it's a 30, is 180. And 3 times 2, no, but it's 30 times 20 equals 600. Okay? And then we add up all the bits. 6, 10, there's the answer, 806. Partial products works every time, but personally I get confused about which bit adds to which bit, and then I've made mistakes in here on the addition part. But everyday math says when problems get cumbersome, we can just reach for a calculator. Another popular algorithm taught in everyday math is the lattice method. Same problem, 26 times 31. This time we have to set up a lattice. It works like this. We put the 26 on top and the 31 along the side like that. And then we draw these diagonals. And then we do 1 times 6 and fill it in like that, 0, 6. 3 times 6, 18. 1 times 2, no effort to say 1 times 20, by the way, 0, 2. And 3 times 2, 0, 6. Now we add it up along the diagonal. 6, 8, 0 plus 2 is 10. Carry the 1. 6, 7, 8, and 0 is 8, and a 0 there. And the answer is read this way. There's your answer, 806. It's kind of fun. It works every time. But even the authors of Everyday Math admit in their teacher's manual why the lattice method works is not immediately obvious, but it is very efficient and powerful. The principal disadvantages of the algorithm are that it is unfamiliar to many adults, i.e. parents, and making the lattice takes time. Well, one main argument against the standard algorithm is that it does not teach place value. And I defy you to show me how the lattice method teaches place value and you still carry, like we did inside the little boxes. Now these algorithms, the lattice method, the partial products method, are wonderful teaching tools. But then why not go on and teach the most efficient and internationally known algorithm? Also, there's insufficient time and practice in everyday math. Students do not master an algorithm. Students do not emerge masters with well-honed skills in their toolkit as they move on to middle school. More on this in a minute. Finally, decimal and fraction multiplication work in everyday math is shallow in content, but that's a topic for another time. Let's move on to division. Okay, the standard algorithm for division, otherwise known as long division. Here's our problem. 133 divided by 6. We set up long division like this. Does 6 go into 1? No, but it's a 100. We're calling it a 1 right now. Then we move over to the next number. Does 6 go into 13 or 130? Why, yes, it does. Twice, because I know 2 times 6 is 12. I subtract 1. I carry down the 3. Once more, I know that 6 goes into 13 twice. 2 times 6 is 12. Subtract that, I get 1. And my answer is 22, remainder of 1, or 22 and 1/6. Here's the problem again, 133 divided by 6. Now in Turk investigations, no algorithm or method is taught. Students reason through the problems and use cluster problems again, like this. Let's see. 6 times 10 is 60. I know that one. And you double that times 2, so that's 6 times 20, and that is 120. That's not quite 133 yet, so I can add another 6 to get there, and that gives me 6 times 21, which is 126. And I'm still not at 133, so let's add another 6 times 1. And I get 6 times 22 equals 132. Well, that's almost 133. It's just 1 off. So I know that the answer is 6 times 22 plus 1 equals 133. So my answer to 133 divided by 6 is 22, remainder of 1. And the corresponding homework from Turk is baffling to parents. Here's one. A cluster of problems. Make up a problem cluster that would help someone solve 187 divided by 13. Include answers to all the problems in your cluster. Most parents go, what's a cluster? How about this one? Solve this problem in 2 different ways and write about how you solved it. 36 divided by 6 equals. Here is the first way I solved it, space. Here is the second way I solved it. If the student just writes 6, they don't get any credit. On page 132 of the Teacher's Reference Manual for Everyday Math, grades 4 through 6, it says, the authors of Everyday Mathematics do not believe it is worth students' time and effort to fully develop highly efficient paper and pencil algorithms for all possible whole number, fraction, and decimal division problems. Mastery of the intricacies of such algorithms is a huge endeavor, one that experience tells us is doomed to failure for many students. It is simply counterproductive to invest many hours of precious class time on such algorithms. The mathematical payoff is not worth the cost, particularly because quotients can be found quickly and accurately with a calculator. In everyday math, the standard algorithm is not taught. Instead, the focus algorithm is partial quotients division, and it goes like this. Same problem, 133 divided by 6. We set up the problem similar to the standard algorithm. Some people call this the magic 7. But we don't do the numbers along the top. Instead, we wonder, see, 133, how many times does 6 go into 133? Well, I know it goes at least 10 times. So over here, I write that. And then I'm going to subtract 60. 3, and hopefully we can do this, 73. Well, I know there's another 60 in there, because I know 6 times 10 really well. There's another 60. Well, I know 6 will go into 13, because I know 6 times 1 is 6. Minus 6. That gives me 7. Oh, there's one more 6 in there. And finally, 6 does not go into 1. Then to get your answer, you add up all of these. 10 plus 10 is 20, plus 1 is 21, plus 1 is 22. And there's our answer, 22, remainder of 1. Remember that quote from the teacher's manual that said that mastery of division algorithms is a huge undertaking and that it is counterproductive to invest many hours of precious class time on such algorithms? So what does everyday math invest precious class time on? Well, these are the student reference books for the 4th and 5th grade. In math class, 4th graders plan a world tour. In this book is a full-color, glossy, 48-page world atlas. Where's the math? And in the 5th grade, students plan an American tour. This is a 60-page U.S. atlas. Also, lots of calculator use is encouraged. In each of these books is an identical chapter, virtually identical chapter on calculators. 35 pages, full color. How to use a calculator. Districts are spending a lot of money on these books. To conclude, if you believe that students should master multiplication and division by the end of 5th grade, you must insist that school districts avoid curricula like Turk investigations and everyday math. All right, I promised to tell you how I got involved in all of this. I went back to school in the late 1990s, early 2000s to get a degree in atmospheric sciences. To do this, I needed a year of calculus and calculus-based physics before I could enter the atmospheric sciences department at the University of Washington. I was terrified. It had been 20 years since I'd taken a math class, but it turns out I did just fine. And I was kind of surprised at how poor the skills were of my colleagues who had just graduated from high school. Common problems included, 1, an ability to work alone, to solve problems without checking in with other people all the time. And there's a lot of group work in these reform math curricula. 2, a lack of fluency in the symbolic language of math, or even the ability to think logically like a mathematician. And this impedes needs like writing a computer program. And 3, a lack of mastery and confidence with basic math skills like trigonometry, algebra, and even arithmetic, and a complete dependence on a calculator. A college professor recently told me that they get students in college who can't do 4 times 6 without a calculator. And now my children are in elementary school, and I know why students are not more prepared for college math and science. Before I finish, if you're a parent with kids having problems in school right now with reform math, may I recommend the very efficient and reasonably priced Singapore math textbooks. You can get these online on Amazon.com or in Seattle at Math and Stuff and tutor your own kids. Very simple to use and inexpensive. Finally, it is my hope that by eliminating curricula like Turk and everyday math, From the math education landscape, we can begin a new era of good math for all students and create confident scientists, mathematicians, insurance adjusters, mortgage brokers, teachers, business people, engineers, architects, computer programmers, builders, retail salespeople, shoppers, parents, and other users of math in the future. Thanks for watching.